Hi all, let's see the next topic of Unit 3 Binary Arithmetic. So here we are going to discuss about different types of arithmetic operations on binary numbers such as addition, subtraction, multiplication and division. So arithmetic operations, they basically involves performing different types of operations on your binary data such as addition, subtraction, multiplication and division. So in this lecture, we are going to discuss about each and every type of an arithmetic operation that can be performed on a binary number with the help of an example. So the first type of an operation is a binary addition. So binary addition involves adding two binary numbers and the result itself is a binary number. So it is one of the simplest type of an arithmetic operation that can be performed. So if you look at the table for the for the addition operation, so there are four possibilities. If you consider this as an operand A, each and every bit of your operand you are going to perform an addition operation. So this is your first operand and this is your second operand. You are going to perform an operation and this is your result. So addition involves 0 plus 0, 0, 0 plus 1, 1, 1 plus 0 is 1 and if you add 1 plus 1 it is not 1. So 1 plus 1 it is nothing but 1 0. So 0 is your result and 1 is your carry forward. You are going to carry forward. So 1 0 is nothing but in decimal equivalent it is nothing but 2. So 1 plus 1 will give you 1 0. So in case of normal decimal addition 1 plus 1 is 2, but in case of a binary addition 1 plus 1 will give you 1 0. So 0 is your resultant bit and this 1 is your carry bit. So let us see an example of binary addition. So I want to perform addition operation on two operands. My first operand is 111101 and the second operand is 10111. So if you consider these two operand, we call the one operand as an addend and other operand as augend. So you're going to add these two addend and augend, which will give me my resultant sum. Okay. So how to perform a binary operation? So 1 plus 1 is 1 0. According to this table, 1 plus 1 is 1 0. 1 is your carry and 0 is your result. So 1 plus 1 is 1 0. So carry will be written here and 0 will be written here. Next, 1. So this carry should also be added next time. So 1 plus 0, 1. 1 plus 1, again 1 0. So 1 is your carry and 0 is your result. So 1 plus 1, 1 0. 1 0 plus 1, 1 1. Remember 1 plus 1 is 1 0. If you add 1 0 plus 1, it is 1 1. 1 1 is binary equivalent is nothing but 3. So 1 plus 1 plus 1 is 3. Same way 1 plus 1 is 1 0. 1 0 plus 1 is 1 1. So 1 1. So 1 plus 1, 1 0. 1 0 plus 0 is 1 0. So 1 0. So 1 plus 1, 1 0, 1 0 plus 1, 1 1, 1 1. So 1 plus 1 is 1 0, 1 0. So this is the previous carry. So 1 comes here. So totally 1 0, 1 0, 1 0 0. You can cross verify converting this into a decimal form. So this decimal equivalent is 61, 10111 decimal equivalent is 23. So the result should be 84. If you convert this, the result should be convert this binary number into a decimal. It should be 84. So this is how you can do a binary addition. We'll see one more example. So consider adding these two binary numbers 1101 and 1011. So if you consider this 1 plus 1, so 1 plus 1 will give me 1 0. So 1 is my carry and 0 is written here. Next 1 plus 0 is 1. So next I have So 1 plus 0 is 1. 0 plus 1 is 1. So next 1 plus 0 is 1. So finally 1 plus 1 is 1 0. So 1 0 1 1 0. This is the resultant sum. Next is the binary subtraction. So binary subtraction is one of the four binary operations where we perform subtraction on two binary numbers comparing only two digits 0 and 1. So if you look at the binary subtraction, so if you subtract 0 minus 0, the result is 0. If you subtract 1 minus 0, the result will be 1. If you subtract 1 minus 1, the result is 0. Similar to your binary addition, decimal addition, subtraction. The only thing you varies is 0 minus 1. So in case of decimal, you get minus 1. But here in case of a binary subtraction, 0 minus 1 is nothing but 1. Because you are going to take a borrow from the next order digit. So that will give you a result of 1. I'll show you how. So let us take this example. I want to subtract 110 from 1110. So 1110 minus 110. So you subtract the numbers in one's column and note down the result. So in this case, if you look, the first case 0 minus 0 is 0, right? So we'll start here. 0 minus 0 is 0. Next, move on to tens place. So 1 minus 1 is 0. Next, we move on to hundreds place. So 1 minus 1, it is 0. Next, 1, the same 1. Since you don't have anything here, you have to consider 0. So 1. So the result is 1000. So let's take one more example. 10 minus 001010. Let's see how to perform a subtraction. So here 0 minus 0. So 0 minus 0 is 0. Next 1 minus 1 is 0. Next 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 0 is 0. And 1 minus 0 is 0. So this is a subtraction. So let us take one more example. Here I have a number 1010. I have to perform 1010 minus 011. So if you look at this, so here 0 minus 1. So 0 minus 1, I have to take a borrow from the next number. So when I take a borrow, it becomes 1 0. So 1 0 binary equivalent, if you take a decimal, it is 2. So it becomes 2. So here when this is borrowed, this becomes 0. Okay. So 2 minus 1 will give me 1. Next, here I have 0. Instead of 1, I have 0. 0 minus 1. So I cannot borrow. So I have to borrow from the next number. Since I have a 0 here, I cannot borrow. So I have to borrow it from this number 1. So when I borrow it from this number, here I get 2. So 2 minus 1, it becomes 1. Okay. So when 2 minus 1 becomes 1, so here it becomes When I am borrowing it from this side, here I get a 2 and here I get a 1. So 1 minus 0, it becomes 1, and this here, now this will become 0. So it becomes 0, 1, 1, 1. Okay. So if you take here 1 minus 1, sorry, 1 minus 1, 0. 0 minus 1, I have to borrow it from this number. So it becomes 2. 2 minus 1, 1. So here I will have 0. 0 minus 0 is 0. So here 1 minus 0 is 1 and 0. So this is how we perform a subtraction operation. So next comes the binary multiplication operation. So it is similar to a decimal multiplication. So the rules for a multiplication is 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, and 1 into 1 is 1. So using these rules, we perform a binary multiplication. So I want to multiply two numbers, 10111 and 1010. So 10111 into 1010. This is very simple than decimal multiplication. So because there are only two possibilities, 1 and 0, you have to multiply the number with either 1 or 0. So first we'll start with this end 0. Multiply this, one is a multiplicand and one is a multiplier. So take each bit of the multiplier and multiply it with the multiplicand. So 0 into this entire number will give me 0. So 0, 0, 0, 0, 0. Similarly, 1 into 10111 is 10111. Similarly, 0 into 10111, so 0 is 0, 0, 0, 0, and 1 into 10111, 10111. So total, finally you add 0, 0 plus 1, 1. So 1, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1, 0. So I have it. So I will get a carry here. So carry here. So 1 plus 1 will give me 1, 0. So 1 plus 1, 1, 0, 1, 0 plus 1. I'll get a carry 1, 1. So this 1 will come here and 1. So I have 1, 1, 1, 0, 0, 1, 1, 0. So this is a simple binary multiplication. Next is a binary division. So binary division is probably one of the most challenging operations of a basic arithmetic operations. So there are different ways to solve the division problem in a binary division. One of the method and the simplest method is said to be called as the long division method. So if you see the rules of a binary division, there are certain rules similar to your other operations. So 1 divided by 1, it will give me 1. 0 by 0 is there meaningless? It is 0. So 0 by 1 will give me 0. 1 by 0 is meaningless. So if you see, say for example, I want to divide a number, binary number 0, 1, 1, 1, 1, 1, 0, 0, and that has to be divided with 0, 0, 1, 0. So here one is said to be called as a dividend and other is said to be called as a divisor. So the dividend here is 0, 1, 1, 1, 1, 1, 0, 0. This is your dividend and this is your divisor. So you have to remove the zeros in most significant bit in both the dividends and divisors, because that does not change the value of a number. So I am going to remove the most significant bits, this 0 and these two zeros. So then I am going to use the long division method. So 1, 1, 1, 1, 1, 0, 0 by 1, 0. So there are only two possibilities here. You have to multiply this particular divisor with either 1 or 0. So for that, you need to check the number. If this particular number, say first I am first dividing this number 10 with 11. So I have to check whether if 10 is less than 11. Only if 10 is less than 11, I can divide this number. So since 10 represents 2 power 0, 3, and 11 represents 4. So since 3 is less than 4, so 10 here. So what you consider? Compare these two digits. 10 is less than 11. So I can perform multiplication one time. So 10 into 1, which will give me, so 10 into 1, which give me 10. So 1 minus 0, 1, 1 minus 0, 1 minus 1, 0. So I am not mentioning 0 because it doesn't have any value. So this 1 will come here, 1, 1. So again, it is less than 10. So sorry, 1, 1 is greater than 10. So again, one time. So 10, again I'll get 1, 1. So 10 is less than 1, 1. Again, one time. So the result is 1, 1. So again it is less than 1, 1. So again one time, 10. Again 10 will come. So again one more time, it will give me 10. So finally I'll have 0, 0. So the result is, the answer is, the quotient is 1, 1, 1, 1, 1, 0, whereas the remainder is 0, 0. So this is how we perform a long division method. Let us take one more example of long division. Say, I'll show you a decimal division. So say I want to divide a number 42 with 6. So 6 sevens are 42. So you'll have a remainder as 0 and quotient as 7. Let us take the same example in a binary form and see whether we get the 7 as a result or not. Divide the number, the dividend is 101010 with a divisor 110. So the binary equivalent of 6 is 110 and the binary equivalent of 42 is 101010. So when I'm starting my division, I have to check if this particular one, the first most significant bit of the dividend 1, will start from there. I'm checking whether 1 is less than the divisor 110. So if the dividend is less than the divisor, then you can do only two things. You can multiply it either 0 times or 1 time. So if when the dividend is less than the divisor, then you have to multiply it 0 times. So I have to 110 into 0. So it becomes 0. So 1 minus 0, 1. So this 0 will come here. It becomes 10. Now I am checking. Still 10 is less than 110. So I cannot perform one time also. So I am multiplying it 0 times. It becomes 0. So it becomes 10. Next, this 1 will come down. So 101. So I am checking it. So 101 is still less than 110. So again I have to multiply it 0 times, which will give me 101 again. And now this 0 will come here, which becomes 1010. So 1010 is now greater than 110. So I can multiply it one time. So 110 into 1, which will give me 110. Now multiply it, you get an answer 0, 0, and here you have to take a borrow from here. It becomes 2, 2 minus 1, 1, and this becomes 0. So now again I get this 1 here. So it becomes 1011. So 1001 is again greater than 110. So if you have a doubt, you can do a binary equivalent and check if these conditions are satisfied or not. So now again I am doing one time. So 110, subtract it, you will get an answer So 1 minus 0 is 1. 0 minus 1, you have to borrow from here. Since I don't have a borrow, I am having 0 here. I have to borrow it from this. So when you borrow it, this becomes 2 and this becomes 1. So 2 minus 1 is 1 and 1 minus 1 is 0. When you borrow here, you will get a 0 here. So 0. So 0, 1, 1. Now again, I have to subtract this 0 will come here. It becomes 0, 1, 0, 0, 1, 1, 0. So again you do it one time. It becomes 1, 1, 0. So and the remainder is 0 and the quotient is 0, 0, 0, 1, 1, 1. You can ignore this 0 bits. So the result is 1, 1, 1. 1, 1, 1. If you convert it into a decimal form, it is 7. So this is how a binary division is performed. Thank you.